Hello, welcome back to my stream. This is day 20 of Advent of Code. Let's transition over before I forget to do that. There we go. And now we're on my screen. I had to reformat it a little bit in order to restart Chrome. Other than that, we're all good. We're good to go. We finished day 19. Actually, we finished day 18 and 19 together yesterday, and it took 3 hours to get that done. So that was exciting. Let's dive right in with day 20. Let's see what we have. Day 20 trench map. With the scanners fully deployed, you turn their attention to mapping the floor of the ocean trench. When you get back the image from the scanners, it seems to just be random noise. Perhaps you can combine an image enhancement algorithm and the input image, your puzzle input, to clean it up a little. For example, I'm not sure what I'm looking at, but maybe we'll figure it out. The first section is the image enhancement algorithm. It's normally given on a single line, but it has been wrapped to multiple lines in this example for legibility. Is that this part here? All this? This is the first section, and then a blank line, and then the second section. The second section is the input image, a two-dimensional grid of light pixels and dark pixels. The image enhancement algorithm describes how to enhance an image by simultaneously converting all the pixels in the input to the output. Each pixel of the output image is determined by looking at a 3x3 square of pixels centered on the corresponding input image pixel. So to determine a value of pixel 510 in the output range, 9 pixels, 510, 511. Oh, sorry. 9 pixels from the input image need to be considered. These 9. And, oh, these 9. Okay. These 9 input pixels are combined into a single binary number that's used as an index in the image enhancement algorithm string. For example, this, starting from the top left, we have ... hash ... and then dot and hash dot. Oh, okay. So we just create 9 bits. So we have 000 1 00010, which is 34 decimal. The image enhancement algorithm string is exactly 512 characters long, enough to match every possible 9-bit binary number. First few characters of the string are numbered as follows, starting from 0. Okay, so that makes it easy. It's just a lookup. Character index 34 is on, so it should be on. This process that can be repeated to calculate every pixel of the output image. Okay. Through advances in imaging technology, the images being operated on here are infinite in size. Every pixel of the infinite output image needs to be calculated exactly based on the relevant pixels of the input image. The small input image you have is only a small section of the actual infinite input image. Thus, the input image consists of dark pixels. Oh, okay. So, right. So we look at a 9x9 dark pixel thing, and it converts to... Okay, so if it converts to dark, then that's fine. Right? We don't have to worry about it. So we apply the enhancement algorithm, 2 times. Truly incredible. Now the small details are really starting to come through. Sure. After enhancing the original input image twice, 35 pixels are lit. Start with the original input image and apply the enhancement twice, being careful to account for the infinite size of the images. How many pixels are lit in the resulting image? All right, well, let's see what the input image is. Okay. Oh. Huh. Look at that. So this is set. And the test has it clear. Right? Yeah. That's annoying. How are you supposed to do that? Because once you enhance it, then all of the pixels that are dark are now light. So you have an infinite number. Right? They're asking how many pixels are lit, right? How many pixels are lit in the resulting image? How do you... The answer is just infinity. Oh, look. Okay. Okay, that makes sense then. So the last one, if they're all set, then it becomes dark again. So enhancing it twice turns all the infinite ones on, and then the second enhancement turns all the infinite ones off. So then we can actually count. How are we going to store this though? What's the way to store this? Do we have a separate bit that says whether or not the infinities are set? All right, well, let's just start hacking. Actually, let's save this input. Oops. And then we'll save test input as well. Let's see, input day 20. And then we have test for day 20, which is this guy, but we have to change it because these lines are wrapping. Inputs, test day 20. Paste that. Yeah, so we have to just wrap these guys. The guy's putting two. Oh, we'll put one there because it didn't end in it out. Okay, that's 512. Yes. Okay. So I think this is the correct test data, and then we have a nice small grid. And you saw the input image was pretty big, so let's move that over here to inputs and take another look at it. Yeah, it's pretty big. All right, it looks like it might be 100 by 100 because my window is 100, exactly 100 wide. So this might be 100 by 100. That's not too bad. All right, so let's get started with setup. The boring stuff. You got to get the boring stuff out of the way first. Mod day 20, day 20, day 20. Make their source day 20. Next year I'm not going to do it with this extra level of indirection. Source day 20, mod.rs, pub fun day 20, println day 20. Okay, checks, builds, runs, we get day 20. Okay, we're good. All right, so how do we store this? Well, storing the first part, the image enhancement algorithm, that's going to be easy, right? We'll say use crate. Come on, crate. There you go. Utils read file, and what we can do is say let lines equals read file, and we'll do the input. We'll do the test input first, even though it doesn't have that infinite thing. We can still implement it with the infinite thing. So let's build a struct, and what are we going to call this? It's an image. Inside, so the image will be stored as we can store it as a hash set, right? For the part of the image we actually have, we'll store as a hash set, and then we'll have because every time we scan, I'm thinking, okay, I was going to put width and height in here, but every time we scan, the width and height is going to grow by like 2, right? Because this tiny image here, let's just paste it in here so I can edit it and visualize it here. So the next time we go through this, we're going to be checking the 9 around the point that my cursor is on right now, which means we have to search up here, which means there's a row up here, and we have to search to the left of this, which means there's a row here, right? And this is what we're going to search. But if the infinities are on, then, okay, I just put dark in there, but we can make it even more, right? If we do that, this could potentially be flipped on or off based on an image, a pixel in our existing image. The one here, we know we can extend the infinity out, so we can just say, well, if it's out there, it's just infinity. So that means every time we do an image enhancement, we're going to be shifting it over and down by 2. So that we can process all of the bits. This bit is going to be handled by the infinity, but this bit needs to be able to be set or cleared. So maybe we just have to shift it over and down by 1. Yeah, so this bit here is going to be set or cleared based on what's in that corner. And same with all of these guys along here. This bit will be set or cleared based on the infinities. Okay, so we just have to shift it over and down by 1. All right, well, let's start by reading in our image enhancement algorithm string, which is just this big guy here. What do we call it? Bits. I'll call it bits. The vec of bools. And then we can just say for C in lines of 0 dot chars, if C is equal to a hashtag, then, oh, we can just say bit dot push. C equals a hashtag. Okay, and this probably can be, probably just say chars.map, blah, 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 but I'm not going to do that. I think this is pretty clear what the code is doing. So this will set or clear our bits from the first part, and now we need to read in the second part, and we don't have our struct yet. So the infinity is going to be a bool, telling us whether or not the infinity is on or off, and that's going to be based on this guy here. If the infinity is on, then we look here to see what the new infinity is. If the infinity is off, we look here to see what the new infinity is. Okay. And then it's just a hash set. Oh, and then there's the map, which is going to be a hash set of let's say I64 to I64, XY coordinates. And then I wanted to store the width and the height, but I want to be able to mutate that. Because it's going to grow, it's going to shift over and down by 1 each time. But also going to be an extra row around all 4 edges. So it's going to grow by 2 in width and height each time we do an enhancement. All right. I'll put it there and then we'll see if that gets difficult for mutatability. All right, so next we just want to read in this guy here, and this is line 1, blank is line 2, and those starting on line 3, we're going to scan each line. So this is going to be the rows, lines 2, no, 2 dot dot lines len, and then we'll just subtract 2 from y to insert into the hash set. We got to create our map. Let mut map equals, let me make this a type so I don't have to type it over and over again. I don't know how many times I'm going to have to type it, but type map equals hash set I64 64. So our map is a map. This map colon map is hash set new, and for x in lines of y minus lines of y dot chars. Oh no, we have to get x and the character. So chars enumerate like that. If C is equal to hash, then we're going to say map.insert x and y minus 2. Is that all we need to do? I think that's all we need to do. Let's print that out. Map, and then see if that looks right. Oh, I forgot to delete this. And hash set doesn't exist. Use standard collections hash set. Oh, right. Why was I doing 64s? Oh, in case I want to check negative. That's fine. Oops. Yeah. Okay, that checks. Image isn't used. That's fine. Okay, so we have 3, 4, which is this guy here. 4, 4. 1, 2. 2, 3. Okay, so it looks like it worked. We were able to successfully read in our hash map. So now we're going to create an image. Image of infinity starts off as false. We have a map, we have a width and a height, and I actually need to grab those. So that width is equal to lines2.len, let height equal, oh, yeah, they're U sizes. Okay, lines len minus 2. All right, so that should check. We got warnings probably because we're not using a whole bunch of stuff. Okay, so now all we need to do is write an enhancement algorithm and then count them. So we just got to call enhance twice. Enhance on image. Call it twice, and then print out day 19 part 1. Oh, day 19. I'm still stuck on yesterday. 1 is just image.map.len. It's so easy. And this failed because enhance doesn't exist. Enhance image is a mod image. Yep, okay. So that compiles. So how do we do the enhance? The first thing we're going to do is take a look at the new infinity, right? Because that's going to affect... Oh, no, we're just going to flip it at the end, right? Because the current infinity is what's going to affect our new map. So we're going to create a new map. And then we're going to go for y in 0 dot dot image dot width height, and for x in 0 dot dot image width, we're going to check the 9 locations around it using oh right, this is where we want to use I64s again, because we want to be able to make it negative and then check to see if it's negative. We use the infinity value. Height as I64 as I64. So how are we going to do the ones around it? Let's create a little array and make it const so we don't have to build it each time, and call it what? The field, the current field. And it's going to be... What type did I make up there? I made a hash set of map. I think it's going to be, because the reason I was thinking that is because this is going to be a complicated type. This is going to be a I64 usize. This usize is going to be used to index into our bits, which we need to pass in. I forgot about that. It's just a vector bool. So the enhancement also needs to get a reference to the bits. And then this usize will index into the bits, because what we'll have is all 9 of them here. Like this. 9 equals, open bracket. And then we just create our grid. So it's going to be, if we're at this point here, right there, then we go -1, -1. Is going to be 256. Then 0, I'm doing XY coordinates. So 0, -1 is 128. Then we have 1, -1 is 64. Now I'll go on to the next line just to line things up. Then -1 for x, 0 for y is 32. We have 0 for x and 0 for y is 16. Cargo format's going to reformat all of this on me, but I'm just lining it up so that I can type it in correctly. And then 0 is going to be 8. -1, 1 is going to be 4. 0, 1 is going to be 2. And then 1, 1 is 1. Okay. So that should, let's get rid of those lines, and then this should check. It does. Okay, good. So let's put those lines back in, and then now we're going to do around the field, and we're going to use infinity, the infinity value from the image to determine if we go negative or greater than the width. So for P or D, delta in field, let dx, oh, x, yeah, let's call it dx. Although it's not a delta, it's the offset. So point x, I32, I64. I can do it this way. X as I64. Oh, I'm already doing that as I64. Plus delta of 0.0. Py is equal to y plus delta dot 0.1. If px is less than 0 or py is less than 0 or px is greater than or equal to image width or py is greater than or equal to image height, then we're going to set this to be the value of the infinity. So if we say if image.infinity, oh, we need to create a value here. Let value 0, because we need to add to it. If the image infinity is set to true, then we're going to say value plus equals bits of, no, not bits, field delta dot 1. Otherwise, if image.map.contains pxpy, value plus equals delta dot 1. Okay. And then after that, after we get the value out of this field, we're going to determine what to put in the new map. So we have a map.insert. Oh, if value, bits of value. All right, we're going to look this up. Our calculated value has to be looked up in this bits array. If it's set, then we're going to set it in the corresponding new map, map.insert. And we're at xy, but we need to shift down and to the right by 1. Right, so going back to my visualization, I think we might need to start negative. Right, let's just pull this, we'll just create a new visualization here of this guy. Oh, get rid of that. Oh, sure. It does it if I hit return, but not if I hit paste. Okay. So I think, right, we were going to do an extra row across the top, and then, oh, I can't do it now. Right, it has to be done there. Okay. So we want, this is 0, 0, where my cursor is now. I'm going to just put the number 0 there. We want to check this location also, because that can be affected by this, but anything further than that can't be. So we actually want to start our image at -1. And go to image height all the way to image height and all the way to image width. Okay. And then we're going to insert, oops, into x plus 1, y plus 1. And that shifts everything down to the right. I have no idea if this is going to work. Once we're done with that, we can now update our image width plus equals 2, image height plus equals 2, and image map is the new map. Does that check? It doesn't. Oh, image. Okay. Cannot mismatch types. What have we got? Expected I64 but found U size. Okay. Ah. Okay. That actually checks. Let's see if it will amazingly work. What are we expecting our number to be here? 35. Okay, we got 35 for this one. Oh, you know what I didn't do though? Okay, I just thought of this, is we didn't flip the infinity. We got to flip the infinity each time. So we got to say if image.infinity, then we set image infinity equal to the bits of 511. Because they're all on, we got to switch it to whatever that is. Else, image infinity is bits of 0. Means they're all off. So we're going to switch it to whatever is on or off. So let's run that. That should still work because bits infinity is always going to be false in the test case. Let me print out the final map and see if it even looks like this. Because if it looks like this, then we're golden. If it doesn't look like this, then we have issues, right? So we're going to say for y. I'm going to do rows first in 0u64 ... image width as I64, not u64, I64. Why don't I do u? And then x the same, except our height. And I forgot the opening braces. Say if image.map contains xy, then we're going to print a hash, else print a dot, and then after that we do a println, and then that should give us, it should look like this. So if it looks like this, then I think we might be on the right track. Okay. I think that looks like that. All right, but this is not dealing with the infinities. We're not testing the infinities, and I don't know how to test that. That's unfortunate that we don't have test input for that. Maybe that was just a trick that we were supposed to see or figure out on our own after failing. I don't know. I'm going to comment out the print code because this thing is going to get very big. It's starting out at 100 by 100. And so it's going to go to 104 by 104 at the end. And let's see if this works. Run. We got 5437. That seems reasonable, I guess. That's the right answer too, so it's very reasonable. All right, so that was good. Clippy. Oh, Clippy has issues. Loop variable y is used to index lines. So we could just say enumerate skip to. All right, I like that. I like that. What's this item though? Source day 20. Let's take a look. And it's going to be y comma. Oh, y comma nothing. Right? We actually, to do this, L, and then, because that's the line, right? So we can just grab the line, and we still need the y minus 2, but we can do it that way, right? I think that might be, oh, it doesn't like that. Expected integer found struct skip. Wait, but I just did exactly what they said. Maybe it should be the other way around. Skip to enumerate. Oh. That's what there shouldn't have been that. Okay, let's do this. Yeah, that might do it. There we go. Okay. And then Clippy is happy with that. Nope. Oh, right. Yeah, I keep forgetting that that's preferred. 65. There we go. Change that to a bool like that, and we're good. Oh, Bejeffus, sorry, I missed your follow 2 minutes ago. Thank you for following. I need to have sound alerts more loud in my ears. Okay, so that's it. Git add source and inputs. Git push. Oh, commit. Day 20, part 1. Git push. Okay. Good. Part 2. You still can't quite make out the details of the image. Maybe you just didn't enhance it enough. If you enhance the starting input image in the above example a total of 50 times, 3551 pixels are lit in the final output image. Start again with the original input image and apply the image enhancement 50 times. All right. So that's just do more. And I think maybe that's to help catch out people who might have just hard-coded a 2x2 increase. All right, so we're going to enhance it twice and then do that, and then we're going to enhance it another 48 times. Enhance. It should have been called zoom and enhance. And then we'll just print out day 2, part 2. How bad could it be? Let's run it with the test input first. Just make sure we get... Oh, didn't mean to do that. Okay. And then, oh, we can just run it here. 35 and 30, 3351. Okay. It took a while, though. It took longer than I thought it would. Let's run it in release mode. Oh, okay, wasn't too bad. 62 milliseconds to do it with a real input in release mode. Wow, took a half a second, but it came up with an answer, and I have no idea if the answer is in a range we would expect, but it is the right answer, so that's good news. Oh, that wasn't too bad. Took about a half hour to get that done. Clippy should be happy. We didn't do too much. Yeah. Day 20, part 2. Let's see how we did in terms of our stats, personal stats. Yeah, yesterday, even though I started it really late, I'm still in the 5,000s, which means that people found day 19 to be really tough. And even day 18, even though I did it a day after it came out, I'm still below 20,000. So people must be finding these later puzzles really hard. And they are harder, definitely. This took 5 minutes, a little over 5.5 minutes to solve for the best guys. Oh yeah, I want to take a look at my other leaderboards here. Oh, look at that. I'm up at 3rd now. For Chael, I'm at here, 9th. Wow, pretty slow. Yeah, I'm in 7th there. Okay. Oh, that's not good. I enjoy watching Alan's videos, so this makes me sad, but you gotta do what you gotta do. And I'm in 7th there. Okay, not bad. So that's it for Advent of Code for today. Oh well, it's for Advent of Code Day 20 for today. I was thinking maybe we could take a look at my Day 19 solution and speed it up a bit because it's pretty slow. Yeah. So this is the rotating the cubes and aligning them. And I don't know good ways to do it. Somebody told me that you can use a linear regression to solve the correct rotation, the orientation and offset at the same time. And that makes things go really fast, but I don't know how to do a linear regression. Maybe that's something I can learn. But yeah, this takes in release mode takes about 50 seconds to run. With all of my other stuff running at the same time, OBS and Pretzel Rocks and Loopback and Chrome. And yeah, it takes almost 51 seconds. But there was something that day 19. Let me just change my stream title here. A previous day's code. There we go. That works. Okay. The one thing I did look at, or was thinking about, was in our rotate code. Where did I put the rotate? Here it is. We're checking too much. We should only have to check 24 rotations and orientations. And I'm doing 4 times 4 times 2, which is 32 instead of 24. So we can cut back a little bit on it. I don't know how much of a speed up that's going to give us. So the first thing I wanted to do was pull out this from rotate and compare. I wanted to pull out the code that does the offset application and just have it return the offset. And then I'll put that down here. So and then I don't think check needs to be mutable anymore if we do that. That's the main reason I'm doing it, so we can just pass that in, just do a rotate and compare, and then we can. Oh, but for point in B. Oh, that's why we can't do that, because we'd have to pass back this. We'll go over clearing check. We want to update all of check's. All of check's values, and check is a hash set. All right, so I guess we'll leave that alone. I thought that would be an easy one, but it's not. Anyway, the reason I wanted to split that out was so that I wouldn't have to pass things down and down and down, because I figured, well, we could just make this block of code something we could call. And that way we can do this inner loop in a callable thing. Like this whole chunk of code here can be called for, oh no, this chunk here. So if can we pull this out and just say rotate around Y? And we're going to pass in, we need a known, which is a scanner, and we need a B, which is our array or vector of scan data. And then we need the check, and that's one reason to pull check out. Maybe we can just keep it here, but then we're gonna need to put it in every spot where we call it, and just say if rotate around Y, known B. We can just, if let some offset equals that, then we can do these. And then up here, I didn't finish this, did I? Yeah, and this can return an option of scan data. Okay, and then this will just go none if you can't find anything. So now what we do is we rotate around Y 4 times here, and then we do that 4 times for each one of the sides. And then this shifts in by 1, and we'll pull the X out here. And then we'll do the same thing. And this is why I wanted to pull that code out, because now it's duplicate code. So this should reduce the number of calls. I don't even know if this checks. It doesn't. Are we mutating B? Oh, we are. Okay. So we need to pass in a mutatable B. Oh. But we give it back. We give it back. Oh, because it has a vec which does not implement a copy trait. I don't want to copy it though. Value barred here after move. Oh. Is that here? Maybe that's here. Yeah, that was it. Okay, so I just needed to do a reference there. Okay. Let's switch back to test data. And then take a look at day 19's test code to make sure I didn't break that. All right, it's 79 and 3621. Oh, right, I got to run the, yeah, so running it not released takes 8 seconds. Okay, Argo run release day 19. And it panics. Oh, did I call it the wrong thing? Where's day 19? It's just called test 1 day 19. Okay, 1. All right, let's try that. And it panicked. No merge found. Okay. So I broke it by doing all of this. But what did I break? So I'm just rotating it 4 times, rotate around Y. I shouldn't re-rotate it here, right? Tanaka91, hi, thank you for joining. I just finished day 20, and now I'm going back to day 19 to see if I can speed it up, because it's very, very slow. My solution is very, very slow. I know that solutions can be faster, so I'm trying, but I'm not good at this stuff, so I'm just glad I got it working yesterday. You stopped at day 14 or so? Yeah, I mean, day 14, which one was that? Let's take a look real quick. Oh, the polymer thing. Yeah, so this was where you had to see the trick was to just keep track of all the pairs. So an NB pair plus a BB pair plus a BN pair. Otherwise, the thing grows too large to store in memory. Yeah, once you spot that trick, then it becomes pretty straightforward. So what broke here? Maybe I should have done it one step at a time in terms of my refactorization. Let's go back to this thing here I had before and shift that in and see if this runs. Tanaka says, yeah, I finished day 14, but day 15 didn't really tickle me to go through it. Okay, yeah, no, I totally get that. I mean, these are supposed to be fun, right? It's supposed to be about fun. It's supposed to be about learning new stuff. And if it's not fun, there's no reason to do it. All right, so I really broke it, didn't I? So we're modifying the points here. We're still doing everything. Okay, let's reset all of this. I did remember to push my day 20 thing, right? Day 20 part 2. I didn't. Okay, git push. Let's just get that up on GitHub before I break anything. All right, so now if I run day 19, the recent challenges have become very wordy, by the way. Yes, I agree. I mean, it's been like this day 19 was huge. A lot of it was the output, but it was huge in to try to wrap your brain around it. I don't remember if that's the same for previous years. I did previous years' problems, and I remember the encode one could get very wordy. This one, today's was pretty wordy too. Okay, so I got everything working again. Now let's see if we can just split that one rotate around Y routine out. So it's just this for loop. Can we pull this out and just call it rotate around Y? It's going to take the known and a check. And it's going to return an option scan data. And it's just going to be this. None. There. So all we're going to do now is in here, we're going to say if let some offset equals rotate around Y, known, and check, then we can return offset. And that breaks because, oh, I don't have B. Right. B is just a copy of, and that's what needs to be also mutable, is backup scan data. And down here, we just need to pass it in. And we still can't return offset. Oh, some offset. And it doesn't like that. Can't borrow because it's already borrowed. Oh. Okay. Alright, that checks. Does it give us the right answer for the test data? 79 and 3621. Okay, so we didn't break it yet. So now what I want to do is see if I could pull this out. Right, so this was the next challenge, was to move this down here. And then throw these 3 lines down here. I'm not going to format it yet because I want to see if this even does work. Maybe this is where things fail. Oh, it gets close. I just can't find that last merge. So there must be one rotation I'm leaving out by doing it this way. Oh, maybe I do it this way. 3. I got to do the rotate first and then do the check. Okay. All right. So that worked. It got the answer in 162 as opposed to the original, which is 219. So maybe we cut it down a little bit. Not by a lot, though. Let's run it on the real input and see how much, whether or not that speeds anything up. Remember, our target is 51 seconds. Doesn't seem that much faster, does it? It should be checking fewer rotations. Right? It should be eight fewer per attempt. And this is where we chat with the viewers. Maybe you can throw some rayon at the problem. Yeah, I mean, that's one way to do it. I did come up with the right answers, and it is a lot faster. Yeah, just make it multi-threaded. I've never played with rayon, so that would be a challenge for me, especially on stream. Learning something like that on stream is can be painful. But it might be just a matter of adding the crate in and then just saying iter or power iter or something like that. Where's the yeah, power iter. Of course, I don't have any iters in here. As long as you mostly use iterators, it's almost a drop-in replacement, and as long as you don't have shared state. Yeah. Rewrite time. Ha! Rewrite this from scratch. That would be painful. I don't know. So we do a for loop here, and we do modify, we do mutate the thing. So we'd have to like create 24 copies of the cube that we're checking, or the scanner data that we're checking, and then farm those out into 24 threads. And then have rayon just, you know, run all 24 in parallel, and then whichever one comes up with the alignment, the correct alignment, will return that. That would be, yeah. Let's reformat this. it looks nice. Actually, cargo format to do it for us. There we go. What else can we do? There was something somebody mentioned linear regression. AOC cubes, linear regression. I've never implemented linear regression before. No, this is not. It would be nice to see somebody saying, "Oh, here's how you did. How I did linear regression for day 19," and then we could try to emulate that in Rust. Well, I mean, we did get something of a speed up, so I'm going to call that a victory. Oh, clippy like this. Okay, we can clean these up. 88, 107, and 128. What did it say for that one? Known. It doesn't have to be like that, and this doesn't have to be like that. And there is some repetitive code here where we call rotator on Y, but I'll live with that. Oh, and then there was one other thing. I thought I had an issue with test. Oh, that was on day 18, I think. Okay. Yep, okay, so git status, git add source, git commit, slight speed up for day 19, and then day 18, yeah, I had a test thing here. So if I say cargo test, it's going to complain that that test is not run or something. Functions used as test can't have any arguments. And this was supposed to be CFG test, like this. Yeah, okay. And this should be good. Add source, git commit -m day 18 fix testability, and git push that. All right, so that's not too bad.